Hi, this is Tom, and in this video we're going to be distributing radical expressions. Let's begin with a warm-up. It's always a good way to start. Begin with a warm-up. So here's our warm-up. If I gave you a problem like 3 times x plus 2, well, you would distribute the 3 through the parentheses. The parentheses are, this is a binomial, and you'd write 3 times an x plus 3 times a 2, and right off the bat most of us would recognize that 3 times 2 is 6, and so we would simplify the problem to 3x plus 6. Okay, another piece of warm-up, let's try this. How about x plus 3 times x plus 2? Now I distribute the x through the x plus 2, I get x squared. Or let me go back for a second. I get an x times an x, and then I get plus a 2 times an x, and then let's do this again. Now I take and I start with a 3 and I distribute it through the parentheses, so I have plus a 3x, and then plus we have a 3 times 2, but notice we just did that up above, and we know that the 3 times 2 gives us the 6, so let's we're going to use that. So I have plus 6, and then let's clean this up. We can write x times x as x squared. 2x plus 3x, these are like terms. I'll write that like terms. And so I can combine that to be x squared plus 5x plus 6. And that terms did not come out very well. Sorry about that. Clean that up. Terms. There. Okay. Now, here we go. This is the extension to a new idea. And we're going to use what we've just reviewed. For example, let's try this. How about the square root of 3 times x plus the square root of 2? So this problem actually serves a couple good points. So let's begin exactly as we did before. We'll distribute the square root of 3 through the parentheses. So I'd write the square root of 3 times x plus the square root of 3 times the square root of 2. Now, here's the first thing we notice is, let's look at this first term here, the square root of 3 times x. Now, notice that if my handwriting got a little quick or out of control, the radical, I'm going to do this in another color, we'll use the gray. The radical might have gotten extended. Say it got over to part of the x. Well, then the reader, or even yourself upon reviewing later, might wonder, well, was the x in the radical or not? And so it's hard to determine. So there's two fixes. The first fix, and I guess we'll show you the fixes here. We'll do them in purple so they're clear. The first fix is that some people will just purposely put a little piece at the end of the radical so that anything after the radical is clearly not in it. Yet this still can cause some issues. So the final fix, and the fix that we're going to be using in our notes and that's most commonly used, is anything that's not in the radical is always written before the radical. So I would write this as x square root of 3. And that is the most common notation. And it really is to provide clarity in communication. Okay, let's continue. Plus, then I have the square root of 3 times the square root of 2 is, remember, since they're both square roots, they have the same index, we can put them both inside the square root. And so our final answer is x times the square root of 3 plus, we already did the 3 times 2, we already know that, that's 6. So plus the square root of 6. Now, let's try this again. We have another example here. Continue in this nice purple color. Let's try this. Let's try multiplying binomials like x plus the square root of 3 times x plus the square root of 2. So the problem begins as we would expect. We'd we distribute the x, so I have x times x, but we already figured that out, that's x squared. And then x times the square root of 2, so we'd write x square root of 2, plus, now let's go back to our black, so plus, now I have a square root of 3 times an x, and I'd write x square root of 3, just like we did above. And then, I make that a little bigger, then I'd have a square root of 3 times the square root of 2, and we took care of that just a moment ago, and so we could write that as plus the square root of 6. And notice that you could do this. You could say x squared plus, you could say these are like in x, and if you did that and factored out an x, you'd have a square root of 2 plus the square root of 3 times x plus the square root of 6, but honestly this is fairly uncommon. And so in other words, we'll just leave the problem in our as we have right here. Okay. Let's try another example. Okay. In this example, we'll try x plus square root of 3 squared. Now, pause the video, try it, and then let's see if you get the same answer. All right, pause it now. Okay, you're back. Wonderful. Now, remember, the squared applies to the parentheses. So it says you take everything in the parentheses and you multiply by everything in the parentheses. So let's do this. Okay, we'll proceed as we expect. We're going to distribute the x's, or distribute the x. So I'm going to have an x squared plus x times the square root of 3. And then we'll do this in blue. Then we're going to distribute the square root of 3. So we're going to have plus x times the square root of 3 plus, now I'm going to write this very carefully here. I'm going to write this as the square root of 3 times the square root of 3 for a bit, and we're going to come back to that. Notice that I have like terms here in the x times square root of 3, so what I can do is this, and let me come back. We're going to take care of all of this at once. Notice this. The square root of 3 times the square root of 3, that's the same as saying the square root of 3 is being squared. That whole piece, you could think of it as that whole piece is being squared. And also, the other way you could think about it is if you were to put everything in parentheses, you could write this as the square root of 3 times 3. And if you do that, well, then you think of this as 3 squared. And we already said that if you take the square root of something squared, the result is the base. Wow, look at all the different ways we can write this. We're going to use the fact that the square root of 3 times the square root of 3 is the same as the square root of 3 squared, and it's also simply 3. All right, so with that, let's put our problem all back together. I'd write x squared. I combine my like terms to get plus 2x square root 3 plus 3. All right, last problem, and that is the example. That is x plus the square root of 3 times x minus the square root of 3. So let's just take it from the top. We have an x times an x, and an x times a minus square root of 3. So I write x times x is x squared minus x times the square root of 3. Then I distribute the square root of 3 through the second set of parentheses. So I get plus x square root of 3 minus the square root of 3 times itself, squared. Whoa. Well, I'm going to bring our screen down a moment because look at this. In the middle, these are like terms, but they're also opposite like terms. Opposite means 3 plus negative 3. Those are opposites, meaning one is positive, one is negative. So the result of adding opposites always add to 0. Whoa, let me get rid of that little dot. Oh, whoops. So I'm going to have to leave that 0 there because, but look at this. So if it's 0, we usually just don't write it. We'd write x squared, and we already decided from up above that the square root of 3 squared is 3, so I could write this as x squared minus 3. And in the next video, we'll see why this is so important. Thanks for watching.